then how you can use the values to identify whether the error is due to the apparatus or error is a random error. So example, if you calculate a percentage difference, how to calculate a percentage difference? It's a maximum minus minimum divided by mean into 100, or the percentage difference. It depends. If a standard value is given, then percentage difference is equals to maximum minus minimum divided by standard value into 100. That's if standard value is given. But if standard value is not given, then maximum minus minimum divided by mean into 100. Like if you don't know which one is a correct value, then this is the way. So what happened? You will compare the percentage error of the apparatus with the percentage difference between the actual value. So what happened if the percentage error, like the percentage error in the apparatus is less than the percentage difference? It means that why your results are wrong. Your results are wrong due to other errors, like other maybe random errors. But if your percentage error due to the apparatus is more than the percentage difference, it means your results are wrong because the apparatus. If your apparatus is not accurate, then percentage error will be high, because sometimes they give you the, like student perform the experiment, student performed the experiment and he's getting an answer 203, but actual answer is 214. So what you will do, maximum minus minimum divide by standard into 100, you got percentage difference as 5.41, and then you will compare this percentage difference with percentage error or error in the apparatus. So when you compare this with a percentage error, the percentage error, as we discussed now, like the smallest value divided by value recorded into 100. So example, your percentage error due to apparatus is coming out 2%. So because of apparatus 2% error, but percentage difference is higher. So what it shows, if a percentage error of apparatus is less than the percentage difference, it shows that the your results are not wrong because of apparatus. Your results are wrong because of other factors, maybe surrounding temperature change. And what will happen? Opposite will happen if your percentage error due to the apparatus is higher. Like example, the apparatus error was say 6% and your percentage difference is 5. So if percentage difference is smaller than the error of the apparatus, it means that error is due to the apparatus only. Is it clear? Because sometimes you have to identify whether the wrong result is due to the apparatus or due to the surrounding. Is it clear? Then for hydrated salt, the term hydrated salt means the salts which contain water of crystallization. We call them as hydrated salt. So using a heating method, heating in a crucible, we can find the number of the water of crystallization or how many water molecules are there. So example, like copper nitrate contains 6 water molecule. How we can identify? So a simple technique is used. So first what we'll do, We'll place a hydrated salt in a crucible and we'll measure the mass of the crucible. Then we supply heat energy. When we supply heat energy, the water will escape. But what we will do, how we'll know all of the water will escape? So we'll repeat the procedure. Like example, we supply the heat energy and we'll take it out and measure the mass after say 2 minutes. Then we'll further supply heat energy, take the mass after 2 minutes again. We'll repeat this procedure until the mass will be constant. So once the mass is constant, what it shows that now no more water is there and all of the water escape. So we will take a difference, like mass 1 will be higher and mass 2 will be smaller. We'll take a difference so we'll know how much mass of the water is there. So after knowing the mass of the water, how to find moles of a water. Moles is equals to mass in gram divided by molar mass. So this will give us how much water is there, or water of crystallization is, or how many moles of water of crystallization are present. Is it clear? So this is a technique which is used to identify or find the moles first for water, and using the moles we can find the amount of water which is released, and that amount of water or moles of water shows the water of crystallization. Then we can simply take a simplest ratio, like if we know the mass of anhydrous, we can take a simplest ratio. As you see in this example, sodium sulfate dot XX2O has a molar mass of 322. When we subtract the mass for water molecule, this is mass of hydrated. Anhydrous mass is sodium 23 multiplied by 2, sulfur is 32, and oxygen 16 times 4. So the mass of anhydrous is this. When we subtract hydrated minus anhydrous, we'll get the mass of the water. And after knowing the mass of the water, we can find the moles of the water. Is it clear, this example? So another similar question related to finding the moles. So 3.51 grams of hydrated zinc sulfate were heated and 1.97 grams of anhydrous zinc sulfate obtained. Use the data to calculate. So first 3.51 is hydrated, means it contains water, and 1.97 does not contain water. So 3.51 minus 1.97, so we get the mass of the water. So we have the mass of the water and we have the mass of zinc sulfate. Zinc sulfate is 1.97, mass of water is 1.58. So we'll get the moles for each, because we need a simplest ratio between the zinc sulfate and water. So moles of zinc sulfate divided by molar mass of zinc sulfate and molar mass of water, which is 18, you get 0.0122 and 0.085. Then divide by smallest value. 0.012 is the smallest value, so you will get 1 and you will get 7. So simplest ratio is 1:7. So if we have 1 mole of zinc sulfate, it means there should be 7 moles of water. Is it clear? Any doubt in this? So this is the last topic of unit one, first topic one. I'll share the assignment with you and you will solve, and I will mention a due date for discussion of that assignment. Any question related to the class today?